Greetings to Inche Anwar. My name is Nagdanesh Vasudevan, 01 DKM 22F 2015. Today I will love to present topic 5 presentation, and we would like to talk about the usage of vector and scalar in architecture. Let's move on with the slide. So for contents, we have introduction, application of scalar and vector selected areas, mathematical solution with the drawing, and conclusion to go through in this presentation. So do you know who discovered vector and scalar? Vector and scalar, both the terms vector and scalar, were introduced by William Rowan Hamilton, who lived in 1805 to 1865. Both terms appear in Quaternius, a paper presented by Hamilton at a meeting at the Royal Irish Academy on November in 1844. For the introduction to scalar and vector, scalar and vectors are two kinds of quantities that are used in physics and maths. A scalar quantity is a physical that has a magnitude but no direction, while a vector quantity is a physical quantity that has both magnitude and direction. As you can see, there is a table in front of you. Scalar is one dimension, whereas vector can be 1, 2 or 3 dimensions. In scalar, any change in the scalar quantity is the reflection of the change in magnitude. However, in any change in vector quantity can reflect either change in direction or a change in magnitude or changes in both. In scalar, any mathematical operation carried out among two or more scalar quantities will provide a scalar only, but if a scalar is operated with a vector, then the result would be a vector. The results of mathematical operations between two or more vectors may give either scalar or vector product or subtraction. For example, for scalar, speed, length, area, volume, time, mass, density, and energy. For vector, the examples are displacement, velocity, acceleration, force, and momentum. So to the next slide, basic vector definition. So independent vector start from any point, or position vector that start from an origin point, negative vector which has the same magnitude and direction, and equality of vector have the same magnitude but in opposite direction. So how is vector used in architecture? While a scalar processor is a processor whose instructions operate on a single data, a vector processor refers to a process that implements instructions operating on an array of data. Vector architecture includes instruction set extensions to an ISA to support vector operations, which are deeply pipelined. Vector operations are on vector registers, which are Z-length bank of registers. Data is transferred between a vector register and the memory system. That's all from me. After this, my teammate will continue the slide. Thank you very much for me.
Thank you to my partner. My name is Ahmad Miradir bin Isamuddin. My registration number is 01 DKM 22F 2016. Let's move on to the next slide. In this slide, we are asked the question of what is theta? Theta O. From the slide, we know that OA is 4i minus 5j plus 3k and OB is 4i plus 3j minus k. And to find the theta, we know that theta, we know that from the equation, vector OA times vector OB equals to magnitude vector OA times magnitude vector OB times cos theta. So, since we can find vector OA times vector OB, there is from the slide here, we already do question is not 8. We only need to know the magnitude of vector OA and magnitude of vector OB. That is magnitude of vector OA set 50 and magnitude of vector OB set 26. We can use the equation here from the slide. That is cos to the power of negative 1 20x set 28 per set 50 times set 26, and we can find theta is 39.05 degree. Now let's move on to the next question. In this question, there are two sub-questions. There is, do you want to find PQ, and second sub-question is, do you want to find 2PQ? From the question, we can find, we know that OP is 5i plus 3j and OQ is 4i plus 10j. So the solution is PQ equals to PO plus OQ. Since we don't have PO, but we know that PO equals to negative OP, so PQ equals to minus OP plus OQ. We can use the basic algebra here and find that PQ is minus I plus 7j. Since we know that PQ, we can times the answer here and find that 2PQ equals to negative 2I plus 14j. In conclusion, only application with sufficient data parallelism DLP can benefit from the vector architecture. The vector processing significantly lower the dynamic instruction bandwidth. Execution time is typically shortened as a result. Vector and scalar is used in architecture to eliminate loop overhauls. Stars only occurring on the first vector element rather than on each vector element, and performing vector operations in parallel. I think that's all for my group. Thank you very much.